Now we are in homework 3, problem 2. In problem 2, we know that the random variable x is uniform in A to B, and the function of this random variable is y equals to the square of x. There are two questions. In the first question, we need to find and draw the density function of y and the distribution function of x. X is because we have the condition of x that x is from A to B. So from the definition and the example, we know that the density function of x equals to this. It's like the conditional probability distribution function. So we got this result when x is no more than a and it's no less than a and no more than b. We got this. So with we have the result of the density function of x. We can calculate the result of distribution function of x. So we got these guys, and with the result of distribution function of x, we can calculate the result of the distribution function of y. And according to the definition, we know that when y is smaller than 0, the distribution function of y is equal to 0. So for y no less than 0, we got this, and it equals to the probability that the large y no more than small y. And we put the square of x into this, and finally we got this and this. So we know the distribution function of y in terms of a distribution function of x. So now we can get the result of the density function of y. We just need to use differential transmission to calculate it, and we got this. Okay, now we need to draw the picture. First we draw the first we got the picture of the distribution function of x. Now x is a simple, so it's very easy to get the picture. It's a simple function of this. So when x is no more than a and no less than a and no more than b, the picture should like this. Is a line, and when x is larger than b, the distribution function equals to 1. It's like step response. Okay, so we got the picture of the distribution function of x. Now we need to draw a picture of the density function of y. Because we don't know the exact value of a and b, so we also don't know the value of the, so we also don't know the value of y under the root sign. So there are two, so we assume there are two cases. So the picture should like so this function should be like this or this. So no matter what the result it will be, the picture should be like this function, y equals to 1 divided by x. So when the y under the root sign is in this scale, so the picture is like this. But when this is larger than b, it should be 0. So it's like the impulse response. So we got the picture of the density function of y. That's the first question. Now in the second question, we have the value of a and b. A equals to -1 and b equals to 3. So we got the exact value of a and b. So we can calculate this. So from the last question, we know that the density function of y equals to 0 when y is smaller than 0 and y is larger than 9, larger than b actually. So like this picture, when y large, when this guy is larger than this, we know that the result should be 0. So that's the first case. Now we have other two cases. The first case is that y is more than 0 and less than 1. Less than 1 in this case, we know that we know that the negative y under the root sign should be in A to B. So we know that this guy should be equal to this 1 divided by b minus 1, b1 minus a, and the value of this is equal to 1/4. So we got this, the density function of y equals to this. And now in the second case, the y is no less than 1 and less than 9. So in this case, the negative root sign of y should be less than a. So this density function should be 0. So therefore the result of the density function of y should be this, and this, the half of this. So now we have three cases. The first case is that when y is more than 0 and no less than 1, the density function should be this and this, and when y is more than 1 and no more than 9, the result should be this, and otherwise this function should be 0. So we have these three cases, and now we can use the definition of the conditional probability distribution function. We got the result of the distribution function of y, and we got these guys. So now we can draw the pictures. We just put this into this, and it's very easy to get the picture, and this to this. So it's very easy to get those pictures. And now we need to find the expected value of larger one of the random variable y. So we just use the definition of the expected value of and we use this to calculate the result. So different cases have different scale. So it's just a simple integral transmission, and finally we got the result equals to 7/3. So that's the second question, and those are the results of the problem 2.